Our next speaker, in a sense, I've already introduced him. His name is Marc Millis, and he was the person who founded the, and was a driving force behind NASA's Breakthrough Physics Propulsion Workshop.
First, a little bit about myself to calibrate the source. When I was a kid, definitely inspired by the Apollo program, 9 years old when watching the moon landing, whole long thing on that. But for recreation, I like to read about technological revolutions, scientific revolutions, whether it was the first airplanes, early submarines, or racing cars, every time they did a paradigm shift. And there was such obvious pattern of how these things happened. And the other thing assumption I made, I figured by the time that I grew up, like we saw in the movie 2001, there'd be moon bases and spaceflight would be normal, which did not come to pass. But the other assumption was that by the time I grew up, rocketry would kind of be reaching the point of where you couldn't really improve it anymore. Well, actually, that one stayed the same. The other part of this is I led NASA's Breakthrough Propulsion Physics project. A short way to explain is instead of looking to advance technology on the laws of physics that we already understand, why not look for further advances in physics that will get you really big breakthroughs? And what I did is that whole pattern recurring, and there's books and books and books of these patterns, is applying that pattern to the how do you run a project? How do you actually overcome the typical barriers? And the other thing we did, the book at the bottom, Frontiers of Propulsion Science, it's the first ever scholarly, it's a graduate level book, comparing the desired breakthroughs of Star Trek-ish kind of flight to the physics that we know for what are the things that you would want to study next if you wanted to push that along. Now, I was asked to talk about what comes next after the obvious, so I should ground what do we consider what are the obvious next step about having effective transportation for Moon and Mars bases. Okay, nuclear is the kind of thing that you're doing. Sustainable habitats and the beginnings of asteroid mining. Took that one further step that maybe, I don't know to what degree you've thought about this, but when you have fully sustainable habitats, that means that the issue about independence might come up. With all this infrastructure, is it going to be coordinated? Is it going to be centralized, decentralized? Or is there going to be arguments or collaboration on how you use it? And with the in-space manufacturing, is it just going to be mining? I mean, going from mining to manufacturing, that's a huge difference. So anyway, getting to the point of what does come next. We're not clairvoyant, and anyone who says that something is impossible or is going to happen, we're guessing. And since we're not clairvoyant, what we tend to do is we extrapolate what we already understand, which is pretty fair, and to go beyond that, we write science fiction. The main point I want to make here is asking what comes next is the wrong question. The right question is that how do we figure out what comes next? What's that process? And so rather than trying to picture what will come next, just crank through the process and see what happens. A huge distinction here is there's a distinction between refining what we already know how to do, which is this sort of stuff, and doing pioneering research. So here we're taking sailing ships and making bigger and better sailing ships. Here we're making steamships. Here we're going from Apollo to Apollo on steroids, chemical. Here we're looking at physics for faster than light flight. By the way, the step from chemical to nuclear is one of these step changes, but the step from nuclear to this is yet another step change. One of the recurring patterns is that every technology follows this kind of S-curve relationship, where in the beginning you put a lot of work into it and you don't get anywhere, but then you reach a breakthrough point where the thing actually works. And then you make all sorts of refinements, but eventually you're running up against the physics limits of it, and you can't exceed that. And to go past things, you have to find a completely different S-curve. You have to do things differently. So rather than making better vacuum tubes, you can go to solid state and get to transistors. Now the patterns on this, okay, jet aircraft exceeding propeller piston propeller aircraft, photocopiers exceeding carbon paper. The list goes on and on and on. The point is making this change is essential and hard. The other thing I wanted to bring out is yesterday I was mentioning about how many advancements we've had with the phones and the technology like that, and the rocket hasn't been. Well, it's not so much that there's been more investment in it or whatever, it's that the telephones are still at this stage. The electronics has not reached this point yet where the rocketry has been up here for decades. So there's a reason why we haven't made that many advancements. The next lesson from history. The point when you start looking for these is you don't wait until the solution is imminent. That's a way of doing financing. Breakthroughs is not a financial thing. When the incumbent technology is reaching the point of diminishing returns, you start looking. When you find clues for entirely different ways of doing it that might circumvent that, that's another good thing. But the third one is that you can actually start pursuing those. There's affordable things you can do to start looking at those. When those conditions have been met, you can start looking. And when it comes to propulsion physics, like non-rocket space drives and faster than light, we are at that stage. There are things that you could do. But part of the question is too, well, which big goals are you going to pursue and how do you figure that out? Actually, science fiction I find very useful for that. And then there's the distilling that down to the grand challenges, to the critical issues that you have to do, and what you can actually work on. But I'm going to put that a little bit, I'll come back to that. The other lesson from science fiction, and this particular book looked at the correlation between all the rocketry pioneers in science fiction, and without exception, all of them were inspired by the science fiction of their day. That's one lesson. The next lesson is that don't consider science fiction to be accurate. It's kind of an inspirational tool, and the example I like to use, and also this is usually also brought up to show the similarities, you know, how many launch from a peninsula and 3 astronauts. A cannon launch and a rocket launch is considerably different. But the one that really struck me that was not in the fiction, which was profound, is that when we finally did land humans on the moon, the entire world could watch it on TV. That was a huge impact on me as a kid, which why I went into space program kind of stuff, because of the kind of unifying thing on that. So anyway, that's one difference. So, what is it about science fiction that makes it so cool? Well, the stories, when you have an engaging story that means something human, it shows what's really the coolest gadgets that you would really like to have. This might sound like kind of a, well, duh, but I mean, it's like one of those things that defining the problem and where to start is not a trivial thing. The other cool thing is the novelty of these things. Taking you out of the familiar helps open your mind to think beyond just mere extrapolations. I'll skip this one for a longer story. But also, when they make mistakes, that's not necessarily a bad thing. That can make you ponder more logically about figuring these things out. So it can inspire and pull you in and get you thinking, which is a very useful thing. Now, the next step is that, okay, so you have these wonderful science fiction ideas, and you have these things that we know reliably. How do you take the next step? Well, the tactic is that on the solid foundations, there's things that we still do not understand, and there are more recent discoveries that we haven't fully grasped. And then with these, there's critical issues unknown that would have to be made true for any of these to be possible. And where those overlap, that's the stuff that you can work on. And which of those actually be affordable to work on, those are the things that you can actually do. And that was the kind of strategy that we did with the program, and that's in the book. Another reflection on past scientific revolutions. There's 2 perspectives here. There's the tool-driven version and the paradigm shift. The tool-driven version by Dyson was that when you have new tools, you begin to see things that you didn't originally be able to see, and that leads you on to new discoveries. And here's the ones that he wrote about, how the telescope allowed Galileo to do what he did, X-ray diffraction to DNA. But here's the tools that we have now that are revealing things that we did not previously see. And actually, I have a whole short course on these sort of things. It's like 10 lectures or so. Would love to expand on that. The other one is the paradigm shift. And the part is when you have a bunch of anomalies that just don't match what you already know, and someone eventually figures out how to throw in a new perspective, but also these things make sense. And our starting points for that are, here are some of the things that aren't really making sense or haven't figured out yet as starting points for how you'd look for those paradigm shifts. Again, these are the kind of intersections. Now this next one, I'm only going to give you some of the early steps on this about a playful way that I've tried to go from science fiction to the beginning of the science. In other words, trying to nudge us at least to the first step of the scientific method. So we start with a cool grand challenge. I would love to have a vehicle to levitate off and fly out without using rockets. And so I start with analogies to known ways that we do it that don't involve science fiction. Buoyancy, a reaction force like a helicopter, and then ask, well, what if I replaced those with an analogy to, say, modifying gravity? Like instead of buoyancy, what if there was some way to turn off the gravitational effects surrounding the spacecraft? Or what if there was some way to zero out the gravitational mass of the vehicle, and you can just go through this whole list of various ideas. And this is another lesson learned in going through these process. One of our common human shortcomings is we usually try and come up with the one solution and to pursue that. At this stage, it's no, come up with as many ideas as you can, and as you dabble into them, see which way they go. One other point I want to make here, this term anti-gravity, which is usually used to encompass this thing, no, that's just one specific way of looking at it. There's all sorts of different things. And then you take this to the next level of question. Well, what if you could zero out the gravitational mass of a vehicle, would that zero out its inertia? And again, you go through a whole bunch of these different things of different questions that take you to. And the ones that are that I know most of what's going on is asking, okay, if you're going to push against space-time itself, what's the reaction mass? And that's a whole nother subject into this. And these also start to give you clues as well, which equations are you going to use to try and describe these and what things you have to do. Eventually, as you distill that down, you get to step one of the scientific method, defining the problem well enough to where it gives you clues where do you start looking for solutions. And in this case, you would want some magical space drive. It has to conserve momentum, has to conserve energy, has to do net external force, meaning not like you're sitting on the inside of your car pushing on the dashboard. That doesn't work. It has to be an interaction between the spacecraft and the surrounding space. And it has to be consistent with known phenomenon. And the clues for where to start look of things that we still don't understand fully, the nature of the quantum vacuum. And here's one, this is so ubiquitous, it's often not even thought about. What causes an inertial frame to exist? And what are its properties? That's a whole separate theme on there. The more obvious ones, we still don't completely understand how gravitation relates to the other fundamental forces. Okay, now back to, that's a little bit of how you begin to explore that. Now back to the point about what sort of headaches do you run into in the time. Over the course of meeting different people and things like that, I've noticed, you can boil it down to a couple of different personality types. The masters who are, want to fully grasp the knowledge that's already known, and the pioneers who love to poke holes in that of what we don't know. And usually those two personalities sometimes butt heads, but the established work are almost always led by the masters, so trying to fit in new stuff in there is difficult. In large part, pioneering work is unpredictable. You don't really know what's going to happen. At that earlier stage, you cannot quantify the benefits at the level that the masters are used to. It's definitely difficult to comprehend new information. Oh, yeah, here's the way of putting it. Every breakthrough idea started as a crazy idea, and there's infamous quotes about people saying things would be impossible. But right along with them, there were a lot of really crazy ideas that were just stupid that we forgot too. So that something sounds crazy is not necessarily a clue to a breakthrough. And there are techniques that we've used to help tell the difference, which is another one. The other one is actually a lunatic fringe liability of not only does this make you look crazy, but which there are things you can do about that, but the more painful one is this attracts crazy people to you. And then here's one that is definitely the case. We already have seen examples in most of our careers that failures are an unpleasant thing. and they're disruptive, but the successes are going to be more disruptive. Some more things about why we have things. We're usually blinded by our success. Our judgments of what's the right way of doing things are by how we've already done them, rather than on what goals are we trying to seek. We tend to focus on the legacy that got us there, rather than on a more open view of doing the future. And one of the terms from some business thing is dominant design. I'll give an example on that. And when it comes to how do we spend our money, we're not interested in stuff that might not work, which is all of the pioneering work. And we insist on hard data where with these pioneering things it doesn't exist yet. Now here's an example of how we can get stuck in old visions. This is the von Braun image that was cast in the 50s of reusable winged orbiters, space stations where you could have astronauts on board looking at weather and other sort of that, moon missions, and then nuclear iron to Mars. And the whole mentality behind this was fueled by being used to World War II scale, large, united, nationwide infrastructure, which does not exist anymore. Cold War fears. And the eventual Sputnik moment that once that happened, it was like green light to let's make this stuff happen. And that was already in the psyche of all the decision makers. So there was not much debate about how to go about doing it. And then what did happen? Well, not only did we have Apollo, but we also had satellites and probes that could do things that previously were thought that only astronauts would be able to do. And things changed. The original space station, the idea is you needed people there to do things like monitor the weather and help relay communication. It's like, okay, you don't need astronauts to do that. That changed. The Cold War thawed, meaning that before, on the Maslow hierarchy of importance, this went from something for survival and security down to where it's just a discretionary thing. And the budgets were cut to roughly 40% of the peak and have basically remained flat. The other one, and this is kind of a twist of fate, NASA made it look easy and safe. The safety record of the whole Apollo thing was amazing, a fluke. And that kind of raised the expectation too high. So in a sense, NASA made themselves a hard act to follow to the point where we have unrealistic expectations of how about going through things. So, what lesson did we learn? So the things that happened, the Apollo was kind of pulling things out of the normal theme, but then we went back to the winged space shuttles and back to some sort of space station. And meanwhile, we had all these other things that were not part of the original vision. All of those are unmanned probes, and some of these the public found extremely exciting. So when it came time, and the version that I'm showing you is for the second President Bush, the baby Bush baby, of when they're coming out with their grand new vision, what did they do? It was the same old thing. The conditions changed, the thinking didn't. It was Apollo on steroids and Apollo on food stamps. That was a mistake, and I'll elaborate on that more. I don't know if any of you have experienced it. I've experienced it more than one time, and it still flabbergasts me how hard it is to unlearn something. Once you get stuck in something in your brain, to purge that out if it's wrong is extremely different. The visions that we grew up with, those von Braun images, for example, they blind us. They so totally consume us, they make it hard for us to see past that. The reason revolutions are generational is because the things that we did that were huge achievements and a big deal, well, they're normal to the people who grew up with them. Also, we see the world as it was when we were growing up. The younger generation sees the world as it is now. So for us to change our way of thinking, to try even smell what is the world like now is difficult. And I know I have that trouble. I'm confused now by how the world is, more so than I was when I was younger. And then the other one is, how many know of things like confirmation bias? Okay. If you don't know about cognitive biases, please look it up, because we fool ourselves so many times on what we think is our rational decision-making process, and no, we have so many stupid traps in our natural behavior that if we don't look for them explicitly, we make bad decisions. Okay, Now, fraught with that, the classic thing that happens is that when you have a new upstart coming into things, the incumbent kind of dismisses them. And when it starts to see where the incumbent is getting some traction, the typical response is the incumbent wants to recapture old glory. Apollo on steroids, and then Apollo on food stamps. I'll fast forward to the next thing. And so this was 2009, 2010, with that grand new vision of what they were going to try and do when they had the first launch of the NASA Ares 9 or whatever. It had kind of an unremarkable and unthrilling future, and it was not inspiring. Whereas you had these things going on at the same time, and these are really actually more exciting, and that was kind of a big deal. So the incumbent fails when their new product, they're trying to recapture old glory, doesn't, and that they dismiss those things. Well, I'm happy to say that NASA has adapted, because that's a traditional thing too. Does the incumbent adapt, or do they try harder to do the old thing? And in this case, the adaptation was to work with these new firms, the commercial spaceflight and the robotic exploration. The main point of this chart is as you guys try and go forward to figure out how to proceed on enabling nuclear propulsion in your vision, the conditions are different than some of the assumptions. Well, I've heard different speakers say different things. Some speakers are looking at things in the context of the more current things. Others are still expecting the World War II era infrastructure and national alignment kind of thing that I do not see as part of our current tools to work with. Right now, we have lots of wealthy individuals who are doing their own space programs, which well, I'll skip that. We have lots of international and other collaborative efforts, and 75% of the things that go on in space now are commercial, whereas back when the von Braun visions and stuff like that was going on, a completely different thing. The other thing about NASA, even though there's been little highs and lows, it's basically been flat for decades, and I don't see any sign of changing. Every time there's been some proclamation by a president when they try and redo the Kennedy thing, again, the error of trying to rehash old visions, they fell flat. It didn't work. That's not the path of success. So as far as the motivations, there's been no Sputnik moments. All the things that the Chinese have done in space haven't, like, scared anyone to action. The motive now is about, well, let's get rich on satellites and mining and things like that. Citizens being able to do things in space. Whether or not it will come to the point where is there a survival threat either by an incoming asteroid, or if we finally get smart enough to realize that the climate is something we actually should be doing something about, that might change things. But right now, instead of being kind of this aligned national thing, we have a whole bunch of pockets of doing things differently. And I don't know if that old total alignment is necessarily the workable success path or not. I'll leave that to you. But as far as, this is my last chart of translating this to advice for you, is that check your ingoing assumptions about what are the current conditions under which you're assuming you'll be able to proceed. And if you have trouble grasping what those might be, bring in a lot more young people, especially smart ones, and ask them, how is the future shaping up from your point of view? And the first answers you get might sound confusing, but they have a different perspective on things because they're growing up with the way things are. The other one I like to say, and I use this on my own internal realm, is that you can spend and burn a lot of time advocating for your particular theme or the big bucks, and you don't really get that much for it. Whereas if you actually say, what work can I do that fits along a critical issue on this, and actually make progress on that, publish both technically and doing it in a trustworthy fashion, and in the public version show how it's relevant and without the hype. That's kind of a sore spot for me on other things. And those smaller pieces start to add up. And for the talks I've heard today, some are actually doing this. And at the risk of overlooking some, I won't mention the ones that come to mind, but I know that when I was in the audience, when I heard that sort of stuff, oh, that's progress. That can lead to somewhere, as opposed to advocacy pitches or trips down memory lane. And also, while you guys are going off and trying to redo nuclear, myself and my cohorts are going to try and be making a Star Trek-ish thing happens. And the other point on that is that we don't all have to be doing the same thing. We can have our pockets of niche skills, pursuing them. Well, I know that this doesn't cost that much compared to that, so it's not like, even if we had 0.1%, the kind of budgets that you're talking about, that would be plenty to do what we needed to do. So that's what I have to say. And oh, one more point. When dealing with people, the other thing I found, and this gets back to kind of the pioneers and the masters, it's easy to find people who are credible, and it's easy to find people who are visionary and can think out of the box. But to find those people that can do both of those at the same time, they're rare, and they're a fun group of people. Thank you.